The sum of the first 5 terms of a geometric series is 5. So that's S5 is equal to 5. Now make sure you go to your log tables and you get a geometric formula if you're using them. So S5 equals 5, and the sum of the next 5 terms is 160. So if you look at that, that's either S10 minus S5 is equal to 160. You know, if you have T6, T7, T8, T9, T10, if you want to find those, then it's S10 minus S5. Or you could just add it all up, like the first 5 terms plus the next 5 terms is equal to 165. So S10 is equal to 165. You go to your log tables, you get your formula, and you just do your best to fill it in. I look here and I can see that S5, A I don't know, or I don't know. It might look like I'm going to end up with a simultaneous equation. I have no idea. And S10 is that. Maybe if I put, and this is where I went to the question, sorry, S5 over S10. So S5 over S10, just so you know what I was doing there. If that over that must be the same as that over that. And I ended up with 1 minus r to the power 5 all over 1 minus r to the power 10. And I decided I'd try and multiply that out, and I just got stuck, which should happen now. Not should happen. I do think this is quite a tricky question. The algebra is quite tricky where to go. I think if I was doing this question side in the exam, this is the one that I'd need a little bit of extra time for, because, you know, I tried just thinking, right, well, what if I got rid of my fractions? What if I multiplied by 1 minus r to the power 10? And I didn't do that. I just thought in my head, well, what if I do that? It doesn't seem like it's going to do me any favours. So then I decided, well, maybe I could multiply by the number 1. Like just a fancy number 1. So this is me multiplying by the conjugate. I'm using my complex numbers. And I multiplied above and below by 1 plus r to the power 10. And I just got to this point and I got stuck. And I just thought, well, maybe instead of multiplying by this number 1 plus r to the power 10, maybe I should multiply above and below by 1 plus r to the power 5. And this is all, you know, it's just frustrating when you keep getting to stuck or to a dead end on it. So I went back in pencil and a different one, and you know, you can see there, that's me showing you that, just look, I tried it that way, it didn't work out. But if I multiplied above and below by 1 plus r to the power 5, I'd end up with 1 plus 5 to the power of r minus 5 to the power of r minus r to the power 10. Then on the bottom I have 1 plus r to the power 5 by 1 minus r to the power 10. I didn't bother multiplying that out because I can see there that they simplify. And I end up with 1 over, sorry, now I better write that a little bit. Just go here. 1 over 1 plus r to the power 5 is equal to 5 over 165. Now I at least, so that's an or there. Now I can at least get rid of my fraction, multiply this by 5, this by 1. I'll end up with r to the power 5 is equal to 32, which means that r is 2. And then I can go back and figure out that a is 5 over 31. I think that to me is tricky algebra. I was trying loads of different ways. I eventually went down a route. I thought I was doing it wrong when that didn't work out, multiplying by the conjugate. And then I just thought, right, well, the only other way I can do this is to maybe try the other conjugate. And if that didn't work, I would have tried something else if I had the time. So just persevere and see what you think with it. And then the next bit is find the smallest value of n for which the sum of the first n terms of the series is greater than 10,000. So a is my first term. I found out that that's 5 over 31. And, you know, in the last part, so 5 over 31, and that's a 2. 1 minus r to the power of n all over 1 minus r. And I want that to be less than, find the smallest value. So I'm going to go for less than 10,000. Looks like I'm going to be using logs at some point. So just clean all that up, use your logs, and you'll eventually end up with n greater than 15.92. So n is 16. And if you're not sure, you can check that out just by subbing in and seeing, do you get something less than 10,000? Smallest value of n for which the sum of the first n terms of the series is greater than 10,000. So 15 must be too small. 16 must be too big. Yeah, I think if I sub that in there, you'll see that.